Welcome to week 4 of developing my own UAV drone swarm without any experience. This week we're delving further into the conceptual design of the plane instead of instantly going ahead and making it in real life, because I realized there's a lot of things that I don't know and still need to think about. We're going to start by trying a few different things in flyout. Then I started reading a book that I was recommended to better understand the basics of aircraft's aerodynamics and conceptual design. And as instructed by the book, we are going to make a clear requirements list with the goals and the thresholds for what we want to achieve. This will make the conceptual design way easier. Now this week is slightly different because then I had 2 days off because I had a boot camp with my college, so I will be talking to you about that because it really felt like a military boot camp. Then I will be going over a quick explanation that I got on batteries to understand them a bit better, which really helped, and I made it pretty clear so that the people watching that happen to not know that much about batteries can also understand it and learn from this. Then we're going to be looking at some research that 2 people did whilst I was away. One of them did research on EDFs, fuselages, wings, and the other person did specific research on toroidal propellers and if we should waste time doing that or not. I'm pretty proud of this video, even though I had 2 days where I couldn't work. I would say welcome, enjoy the intro. We are trying to develop an affordable UAV drone swarm capable of lifting 5 kilos per drone to deliver packages in dangerous areas like Ukraine's frontline or delivering food in the Gaza area. I am only 19, but I am documenting how I am achieving my dreams and how you can too. This is Navius. Hi there. Sunday and yesterday on Monday I've been editing for more than full time. I think in general, the past 3 weeks I've been working for like 10 or 12 hours on average every single day, so also during the weekend, and I think half of that time is spent on editing and making YouTube videos. Now, I don't want that to be my main focus. I do enjoy making YouTube videos, but I do not enjoy the editing, so I kind of want to take a different approach. Currently, I'm just going to record, then the same day I will edit what I do record, and then at the end of the week I can just make it all into a nice timeline, and then it'll only take me 3 hours to finish. So I just received an email about somebody that's pretty smart. I didn't ask if I can show the email just yet, so I'll go over it when I do now. But basically he thinks that we can massively improve this design, like way better. I know that I keep saying like next week I'm going to build it or start engineering. Apparently that's unrealistic, and it's hard for me to know because I'm not experienced. But I think it's good for now that I go into flyout real quick and try a few things out. I kind of want to make a longer, bigger aspect ratio plane, kind of like the thing that I did last video that I said failed. Now he did also recommend that I just should try it out in OpenVSP because it has a lot of simulations. And I got a lot of comments about OpenVSP as well, that it's really good. So I should do that, but I don't know if I should do it if I know it's not going to be the best. There might be a better way to do it, so I'm just going to test it out of flyout instead, because I know how that works a bit better. And it's kind of fun to do as well. I think we should kind of try and iterate on this design for now. I am not looking forward to tomorrow. I need to go to that bootcamp thing and they're not telling exactly what you have to do. So I'm really not looking forward to it. And I know that it's going to be hard to make a good video this week. So I hope that this video will be good. You'll have seen a warning if it's not. When you're watching this, I already finished it. So jealous of future me. Okay, I got this now. The shape is still a bit weird, but I don't care. So from the NASA person, he also recommended me to make the canard a bit smaller, as small as possible while still having control authority. And let's also change up the aspect ratio. Okay, so technically speaking, I should be able to make this fly if I fix the center of mass real quick. I just feel like it looks a lot better, but like I said, everything you expect to fly does not fly, and everything you don't expect to fly does fly. Oops. Okay, let's see. I want to just basically test out if it glides well. I have plenty of authority. Yeah, the weight of the plane actually tends to be very important. 3 tons. All right. There's not a whole lot I can do about the weight though. So it must be the batteries. The batteries take up about 60% of the weight, I think. Cannot do math. Let's make it a bit smaller. Although it should be able to carry a lot of weight, so not sure how I'm gonna achieve that. I must say that the propellers do brake. Currently, this is quite impressive. Okay, it's dipping again. Yeah, it's really dipping. I feel like really the only way to increase how much weight this can lift is by just making the cord longer, and to keep the aspect ratio high, you just need a longer wingspan. That's a bit hard, but let's just do it anyways and test it out. This is a crazy aspect ratio. Should I use a dihedral or something like that? Or should I use swept wings? That's actually a good idea, I feel like. If I use swept wings, maybe it's less good for slow speeds, but you can have a lot more wing area, I think, without going over the 3-meter wingspan that I wanted. I'm just going to make the wings go a bit lower for now and fly out. It's not realistic enough that it's going to disrupt each other. Okay, if this doesn't fly, I mean, in relation to the wing, this wing will have less authority though. Maybe that's going to be an issue, I don't know. Let's give it a try. Yeah, wait, I got the flap issue. I think if I make the roll surface at the wingtip, it'll have more authority. I don't know to what extent that's true, but so let's go ahead and test this out. I just asked the guy that I was talking about if he would like to make some sort of a sketch of like how he would have done it, so I have a better idea of it, because I noticed that it takes way too long for me to do it on my own. Control surface is not placed very nicely. Okay, but it is capable of flying a lot slower. Okay, so I'm basically giving it very little thrust right now, and it's flying very well, like this. Now, obviously, this is quite an insanely big plane. I guess it makes sense, but I'm not used to building something and it working after the second attempt, so that's nice. The control surfaces are horrible though. Okay, it's too hard to steer. Alright, I'm just going to add another control surface right here. I don't know if that's going to do enough, but we'll see. Okay, now it's a lot more controllable. That's nice. We need the gearbox set a little bit differently. So I'm putting the final drive on 2. I'm gonna put gear 0 at 0.4. This one on 0.6, 0.8, 1, and then 1.3. Okay, that does help a lot. The propeller settings. Okay, so I'm currently gaining altitude with only 300 kilowatts. Alright, so the sounds were too loud, so I'm going to do this in a voiceover, but I was quite impressed that I was able to make a plane fly pretty quickly, like in the 2nd or 3rd or 5th maybe attempt. And I figured out that I made the battery smaller, but that did allow it to fly way more efficiently and slower. And this kind of gave it a longer range. So that is also something we are going to have to calculate in the future, because bigger battery doesn't mean better. And it would also save a lot of money if we have smaller batteries, because they're really expensive. I'm not entirely sure how to calculate this or if that's even possible. Maybe I'm talking nonsense, but if you have suggestions, please let me know in the comments though. So then I tested out the plane a bit more thoroughly, and here are the things that I found. It had a 1:7 glide ratio, which was about 2 better than the other things that I tried. It had a 150 kilometer range at the skill I made it in flyout at least. The stall speed is 140 kilometers an hour, which is still slightly worse than the tandem wing that I made. I can still imagine that a tandem wing is quite good, but people told me it's not really a good idea, and I still don't fully understand why and what the implications of this are. But it did need like 4 times less power to fly and even slightly climb. So I wanted to tell you real quick that the guy that emailed me also recommended me a book, Simplified Aircraft Design for Homebuilders by Daniel P. Reymer. So I don't know if it's good. It probably is, but either way, I got it. I'm gonna read it. I have this smart idea where I just copy the text and put it in a text-to-speech bot. If you didn't know, on iPhone you could just take a picture of text, and then in your gallery it'll automatically scan the text, and you can just copy all of the text. So if you don't want to read a book but you want to listen to it while you're doing something else, you can do that and put it in one of those free text-to-speech apps, and then you basically have like free audiobooks. Pretty nice. Well, not free, but If you have the book, it's free. So I went through like 15 pages real quick. By the way, I am quite a slow reader, but I did get to the part where the book told me to make a list about my goals and my thresholds. What do I want the plane to be able to do in specific numbers? And if that's not possible, what's the absolute minimum that I can accept? So let's go ahead and visualize that and put it down in a Figma file. Haven't used it in a bit, but it's a really nice software. I'm way too perfectionistic, so be aware. All right, here we go. Now in here, we can just write down all the requirements. Added payload. So what I mean with added payload is like what you can hang under it as a customer. So currently, obviously, this is extremely important. The goal is 5 kilograms and there is basically no threshold, to be honest. I don't need more than 5 kilograms. There's honestly very little room for less. So, I mean, 4 kilograms, no, I just want 5. Okay, fine. I'll settle with 4.5. I don't even think I'll settle with 4.5. I'm looking for perfection here, especially at that field. Now we're going for 5 kilograms. Then we have the wingspan. I'm looking for a max 3 meters. So let's say 2.7 meters would be even nicer or better. But I will probably end up with 3 meters considering the other requirements. So for weight, drone itself, I mean, I think the maximum of the drone weight itself is probably dependent on the motors I'm going to use. But I'm aiming for about 10 to 15 kilos for the total package with the payload. Preferably like 3.7 kilograms. I don't know why, but I feel like that's doable. But it's probably not. But the absolute max is 10 kilograms, so there is a lot of wiggle room there. Drone length. So the length of the drone, so not the wingspan, but the other axis. I'm expecting it to be like 0.8 meters. Let's just put it at 1 meter. It doesn't matter too much, it's not too important. But it does need to fit in a van, and usually they're less than 2 meters. So I think the absolute maximum should be around 1.7 meters. In terms of dimensions, we also have the height, of course. Now it needs to be stacked on top of each other. That's actually quite important. So I hope the height of the drone is like 20 centimeters or shorter. 20 centimeters is quite a bit. It's still fairly thin, but it's not that thin actually. But the absolute max is 30 centimeters. So let's move on to the batteries. Okay, so for efficient mode, the range is hopefully 2 hours. 2 hours and then I don't know how many kilometers. I don't really care too much about the kilometers. I mean, I do care, but I have no idea how to guess what that is in kilometers, roughly. We will be able to calculate that when I enter in the speed. Then I can calculate that, or then anybody reading this can also calculate it technically. Of course, with range, it is quite a high priority to get this even higher. It would be very nice to have even more of this. If we manage to get a 2.7 wingspan, I don't care that much if this goes to 3 meters, if that means we can get like 2.5 hours more range. So that's what I mean. So for the batteries, the type of battery, I don't really know yet. So somebody actually emailed me.
Email from a viewer. Hi, let me introduce myself. I have been an FPV pilot for 4 years, and since becoming interested in drones, I've always wanted to build one for rescue missions, so your project really speaks to me. I watched your videos about the Navius project, and I think giving you more details about the batteries would be useful. To start, 1C is equal to 1 times the battery capacity. For instance, if you have a battery of 1200 milliamp hours and you charge it at 1C, you will use a current of 1.2 amperes.
Now, I did look that up, I did find that out, but I'm still pretty bad at the fundamentals of electronics.
However, when you see 120C on a battery, that indicates the discharge rate. For example, a 1200 milliamp hours battery with a discharge rate of 120C means it can output 144 amperes at a given moment. Maximum discharge current at a given moment equals the battery capacity in ampere hours times the discharge rate, so 144 amperes equals 1.2 ampere hours times 120 C. Discussing the difference between LiPo and lithium ion. A LiPo battery ranges from 4.2 volts when charged to 3.5 volts when discharged. Meanwhile, a lithium-ion battery ranges from 4.2 volts when charged to 2.5 volts when discharged, for the same capacity. You have a longer discharge curve on a lithium-ion battery, but a lithium-ion can output less current at a given moment than a LiPo due to its technology. Here is a simple example I've created to explain the difference in discharge rates.
LiPo, lithium ion, duk 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 duk. So those are the sound effects that I assume each battery makes. I really wonder, because this makes sense, but also it doesn't, because I don't know how batteries work. I know it's a bunch of chemicals, and I know roughly how batteries work, but not like, I mean, I just gotta take his word for it that it's kind of like this. But I do understand it. This runs out quicker, and it has a lot more as well. This runs out slow, but a little at a time. Makes sense.
Lithium-ion batteries can go higher than the written discharge rate, but that will damage the battery. Here is another diagram on lithium-ion and lithium polymer battery discharge, so you can better understand the subject, I hope.
Typical lithium-ion discharge voltage curve. Okay, so I assume, because you cannot use the entire battery, I know that, so I think this includes that part you cannot use. So this is a very, very steady line. So I assume that between here and here, roughly, you can use the battery at that voltage. So this is the one for the LiPo. This really does a good job at visualizing what he's talking about.
As you can see, lithium ion can still operate at 3.5 volts, but lithium polymer can't. That's the main difference. I need to verify, but I think DJI drones use polymer lithium ion, a mix of both technologies that provides power like lithium polymer and flight time like lithium ion.
Thanks to this guy for sending this email and explaining everything pretty nicely. If you would like to send an email and explain me stuff like this, then you definitely should. I think it's very informative, and it was a very easy way of learning stuff. So thank you. And I will still look into the DJI batteries and all of those kind of things a little bit later this video. But we're going to fully delve into the motors and the batteries even later on in the series. I'm so happy that I record everything I do here, because I feel like this will be invaluable. If this project will be very successful, then people will want to see all of this. And it's just super cool to do something no other company does. But because there is a reason that companies don't show everything they do like I do. But in my opinion, I think it's worth it for me. I wish I had someone that made videos like these. And I feel like I'm bringing many dreams together. I feel like I have a dream, but many people that watch me and watch this right now probably also have a similar dream. People reach out to me with similar ambitions and ideas. And I feel like I'm bringing all of those together into one amazing place for everyone to see. And in the meantime, we're using that all to help people in war zones and stuff, bring them food, etc. It's just a win-win-win-win-win situation. Okay, so for the batteries, I still don't know what type of battery I need. So for charge time, I'm not too picky, but I guess for like quick missions where you only need the swarm for 2 hours, it's fine to have a 5-hour charging time. But if you need it to quick charge, which I do want it to be able to do with like a generator, with just like fuel, I would not say it should be a longer charge time than 6 hours. And I think that's already quite a lot, actually. I think we should be able to make this a lot better, actually. Let me just bring it down a bit. I think 4-hour charge time should be doable, but this is, I don't know how realistic these numbers are at this moment. So don't worry too much about that. Quick charge with generator. Now this refers to when you're on the field, when you're actually operating a drone swarm and you need it to be constantly in the air, you can just have a generator on site constantly charging the batteries, and you can just hot swap the drone. And then I feel like it should be a 1-hour charge time or less, preferably even less. Basically with a 2-hour flight time, you can basically take 2 hours to charge it, but then you would have to charge multiple batteries at once. So I'm just putting it at 1 hour and as the absolute max, 2 hours. Okay. So I put hot swappable in there. That doesn't require any numbers. Now, to be honest, I have a lot of American viewers and people that help me out, so I might have to convert all of these numbers real quick. So last video, I don't know if you watched it, but I asked about this calculation for aspect ratios. And I was a bit confused with that calculation because it had to do with like dividing the wingspan with the area of the wing in total. So in my head, I was like, hold up, what if you're American and you use different metrics? Different, is metrics the word for this? I don't know. You use different type of numbers, you use feet and stuff like that. So then you would have a different answer to that equation. Apparently that question wasn't even that dumb. This is actually apparently just a big hassle for many companies. So like each company has their own standards. And that rocket that once crashed, that also had to do with this exact thing I talked about apparently. So I'm very happy to know that my question wasn't too bad. It still leaves me a bit confused though. I cannot imagine this is how it goes, but okay. Luckily hours are all the same everywhere else, so that's nice. So it's currently 10 p.m. I'm going to sleep and try to edit what I just recorded. But I'm making some nice progress for a day I wanted to have today off, to be honest. But I'm still quite happy with what I managed to do. So see ya tomorrow. No, not tomorrow, because I'm going to the boot camp. I hope it's going to be nice, okay? Not looking forward to it, but okay. I just got back from the boot camp thing that I had with my college. All right, I'm back. Let's continue on this list. So I'm currently editing and I have the issue that both the voiceovers sound exactly the same. That was peanuts compared to that. So I quickly differentiated and I want to talk about my bootcamp, but whilst working on the list, I also talked about what I'm doing. So I also want that to be heard. It sounds exactly the same, so you cannot tell the difference. So it's really confusing. It's as if the list is part of the story. So I have a solution, okay? This song right here, I'll put that under the story. And then when the music goes like this, I will be talking about what I added to the list, okay? That makes it a bit more clear, so we all understand it. So the bootcamp was horrible. So I already kind of expected something bad. You can tell by the earlier footage that I was not very excited to go. And that was more than rightful because it was worse than I expected. It was literally a military bootcamp. The instructors were veterans and they actually had a lot of crazy stuff to pull through, and they like jumped out of airplanes, etc. They had times where they couldn't eat for 3 days. And actually, I really thought it was good that I did something like this because it really gives me more respect to the soldiers on the field and to the people I'm helping out, because they go through hell. You cannot imagine until you try something like that, or if you're an actual soldier. I still cannot fully say that I know what they go through because I haven't experienced exactly what a soldier goes through. Probably what I just did was peanuts compared to that. So I quickly differentiated the horizontal flight from the vertical flight. So I want 2 hours flight time horizontal while still having enough battery to do 10 minutes of vertical. I made the charge time 6 hours as a goal with a max of 9 hours, and it's really too much. For the motors, I quickly looked some stuff up, like this very useful post. He basically tries to make exactly the same thing that I'm trying to make. And he also struggled with finding the right motors to give enough thrust to reach the 2-to-1 thrust to weight ratio that they usually say drones should have. Now, a guy commented on that who already made 2 similar drones, and this one is slightly larger. And he figured out that because we just need to get the drone to take off whilst not being very agile, you should aim for a 1.2 to 1.5 thrust to weight ratio. So I put in here 1.5 thrust to weight ratio as goal, and then the threshold is 1.2. And that really makes it a lot easier even to make our main drone heavier, because that's probably going to happen. For now, I made the limit of the prop size 15 inches, aka 40 centimeters. I know this is still pretty big, so we are going to have to think about that in the conceptual design. That is why we are writing these things down, so we know all of that when we're actually going to design some stuff. So then the first day was pretty mild, so I was like, I guess it's pretty okay, it's quite fine. We had to set up all of the tents with specific dimensions, like it had to be 1.5 meters apart and exactly in a row and like placed correctly, and we had to do it like 3 times over because it wasn't good. So that really showed us that we have to do it correct right away and we have to listen what they say. So then at 6 a.m. we were all woken up and we had to be outside of the tent within 1 minute. I didn't even have time to put my shoes on, so I was outside without shoes, and we had to start with a few boot camp thingies, and then we had like 5 more minutes to quickly get our shoes on, get everything we need. We had to get these 6-meter long logs and we had to carry them, sometimes above our heads, and this was all at like 6 a.m. roughly, and we had to walk through the forest, and eventually there was this ditch with water and we had to just walk right through it with the logs, still carrying the logs, and it was a dirty ditch. It was very gross water. I would not be surprised if it was like sewage. I don't know if it was. Doesn't sound very safe. For the minimum speed without stalling, I put it at 30 kilometers an hour. I don't know how realistic that is, so I put the threshold at 40 kilometers an hour. I really don't think it should be worse than that. Otherwise, it's going to be very hard to use this for search and rescue missions, although maybe it is possible still. I'm not going to set a max speed because if we have a VTOL with all motors being used in horizontal as well, then you can be pretty certain that it'll be more than fast enough. And I mean, it's more about how far it can fly and not how fast it can fly. I will be changing the max weight of the drone itself to 15 kilograms, and the goal of the drone should be around 10 kilograms or like 12. Otherwise, it's probably going to be unrealistic, and we need to house a lot of things to make it capable the way we want it to. 20 kilograms times a 1.5 thrust to weight ratio is 30 kilograms worth of thrust. Now 30 kilograms of thrust at 20% throttle is 6 kilograms of thrust at the efficient mode with 4 motors at 20% thrust. And we had to do so many more things. Like we had to carry those logs to a beach, and then we had to dig underneath the log because the log was like an imaginary wall, and if we accidentally touched the log, then we had to start all over again. And we had 17 minutes to dig a hole, get all our 40 people underneath the hole without touching the log or the like imaginary wall, and we had to get all of our 17 military bags under it as well. We also got these military food kits, and it was like the real thing that they get in the military as well. I have no idea how they got those kits because it says on the package that you're not allowed to sell it or even buy it, but I guess they have connections because they were in the military themselves and they still help them out a bit. But yeah, that was honestly pretty crazy. I have a lot of muscle pain right now. Today I slept 14 hours, so I think it's pretty good. I'm pretty proud of myself for going through all of that and not giving up. But back to all of the numbers, and I'll explain everything. Oh, I did ask a few people in my Discord to do some research on toroidal propellers and on EDFs versus ducted fans versus propellers and other stuff, so I will go over all of that. They did some really good research, and they put it in some PDF with some graphs and things and explained everything really well, so I will go over that later on. According to ChatGPT, a 0.3 thrust to weight ratio at the efficient horizontal flight mode could roughly result in 50 to 200 kilometers an hour. Why did I calculate this? Well, it helps me figure out how much range it will have. The 0.3 thrust to weight ratio is based on the 4 motors running at 20% thrust in the efficient mode, creating 6 kilograms of thrust and the weight of the drone being 20 kilograms. And as ChatGPT said 50 to 200 kilometers, we're going to take the average of that. That's 125 kilometers an hour times 2 hours is 250 kilometer range. Obviously, this is a very rough estimate. and maybe it's unrealistic, but I think it's a good goal. I would love to have 250 kilometer range. If it's 200 though, that's also fine, so let's put it like that in the threshold. A long range allows people to be very far away from any dangerous area that it needs to deliver a package in, so that is quite an important thing as well. Improving the range is going to be a whole thing of its own, so maybe it'll be even better than this, but these are all things that we can optimize later on, and I don't want to set unrealistic goals. So for the radio range in the transmission section, I put it at 150 kilometers or 93 miles. Now you may just think like, why is that? Because the range is meant to be 250 kilometers or 155 miles, which is more than this. Now let's say this is my plane, I want to go from A to B. The distance between A to B cannot be 250 kilometers because if the drone has 250 kilometer range, you can go here, drop the package, but then, yeah, it'll just crash here. If the range is 250 kilometers, it can obviously only get 125 kilometers of range, and then it can go there and fly back. However, it is a little bit complex because it'll still have its package on hand when it's flying to the target. So this should probably take more power than the way back when it lost 5 kilograms. So I don't know exactly what the calculations will be for that. So I think we're going to need more transmission than 125 kilometers, which is why I put it on 150 for a little bit of excess range. Now this is radio range for the controller, so not for visuals. That is a bit more complex. We might think about satellite stuff or maybe something with Starlink. I don't know. We gotta really think stuff through. As you can see, I put SIM card compatibility in here as well because in countries where the SIM towers are good, this would be very useful. And then you kind of have unlimited range. And I want to be able to have a local pre-programmed flight plan because obviously it's going to be a drone swarm. And if we lose control, it'll still know what to do. Now, obviously, we do need some sort of a confirmation before it drops packages as sort of a safety measure. So we need to think about that as well. For the flight computer, I don't really know just yet what kind of things we need to consider with this. I haven't looked into it properly, but it should be compatible with ArduPilot or something that is similar to it so we can do all of the flight controls and stuff like that from there. I believe that's a pretty easy software. So I think for now that is everything I can think of that I can put on this list. I have some extra room here. Please leave some recommendations on other stuff that I forgot to put in here, and then I'll also think about that in the next video. So whilst I was at the bootcamp, I asked a few people to do some research for me on toroidal propellers and EDFs versus normal propellers versus ducted fans. So let's go ahead and go over that.
Unmanned aerial vehicles, or UAVs, come in many shapes and sizes. Our goal is to find a middle ground between the Fly 380 VTOL and the VTOL UAV prototype as seen in the diagram. The fuselage is crucial for aerodynamic efficiency. An elongated, oval or circular shape is common in these designs to minimize drag while optimizing storage and structural strength. The fuselage featured in your video fits this criterion well. Considering future upgrades, such as radar cameras, an enlarged nose might prove advantageous. For the wings, the requirements point towards slow and efficient flight, necessitating low drag and high lift. A flat-bottom wing design is preferred for its manufacturing simplicity and effectiveness in achieving these flight characteristics. The Clark Y airfoil emerges as a suitable choice, offering a good balance between drag and lift, especially at speeds under 150 kilometers per hour. Moving on to propulsion, the difference between an electric ducted fan (EDF) and a general ducted fan is subtle yet significant. An EDF system includes an electric motor housed within a duct, propelling air to generate thrust, suitable for small to medium-sized UAVs due to its efficiency and quiet operation. In contrast, ducted fans can be powered by various sources, including electric motors, combustion engines, or gas turbines, and are not limited to electric propulsion. Nozzles on EDFs can increase thrust, but at the expense of higher power demand, which may not be efficient with cost-effective motors. Experimentation with 3D printed nozzles might optimize thrust without significantly increasing power consumption. In summary, considering propulsion, efficiency, and manufacturing cost, Electric ducted fans, EDFs, seem preferable. For motor size in EDFs, a balance between power consumption and thrust output is key. Larger EDFs, like 120 mm, can produce the required thrust at lower power levels, extending motor life and offering better speed control, making them a potentially ideal choice for integration into the UAV's design.
Toroidal propellers, are they worth it? What are toroidal propellers? US 1TO836466B2 showcases a technology that could replace shrouded propellers, potentially offering reduced weight, noise, and increased thrust and efficiency. Toroidal propellers, characterized by their donut-like shape, aim to minimize wake turbulence typically generated by standard propellers. This turbulence creates noise and drag. To mitigate these, either encase a regular propeller or design it tipless, as with the toroidal type. A simulation demonstrates the difference in lift generation between flat and toroidal surfaces, with research indicating a 40–60% improvement in lift-to-drag ratio for ring wings over traditional flat wings. Can toroidal propellers be used for stealth drones? Partially, yes. Toroidal propellers are quieter, shifting noise frequencies beyond human hearing, which can aid in stealthier operations. It's unclear how they affect radar cross-section. However, changing sounds to less detectable frequencies might facilitate more discrete missions. NASA's studies show a 30 decibel reduction significantly lowers annoyance levels. Summary: testing and manufacturing effective toroidal propellers are challenging due to the scarcity of existing designs and the complexities of scaling. If a suitable size is found, optimization around it could be viable, though extensive experimentation might be necessary. Although recreations have achieved around 80% efficiency, proper testing and manufacturing could improve this. Key testing aspects include balancing, airflow analysis with smoke, and thrust measurement to ensure functionality and efficiency.